Insertion sort is another sorting algorithm in computer programming that runs with a time complexity of O(n) squared. But there are times when insertion sort can be faster or can be improved. For example, if you are sorting a small array, insertion sort can be faster than quicksort. Insertion sort is used to sort array from smallest to largest or from largest to smallest. If I head over to the Wikipedia page for insertion sort, they have a good demonstration how insertion sort works. I'm going to implement the code on how to create an insertion sort in C++. So the first thing I want to do is create a function, and my function is going to be void. It's not going to return any value, and I'm going to name the function insertion sort. Inside of the parameter, I want an array to pass through, and I also want the length of the array. So the first thing I want to do, I want to create a loop that will go through the whole array. So inside of the main, I'm going to declare my array, and my array is going to be 10 integers, and I'm going to 2, 5, 1, 4, 3, 6, 8, 7, 0, and 9. So that's going to be my array, and I want to create a for loop inside of my sort function to go through the whole list of array. So I'm going to start with 4 and declare an integer I, which is going to be my counter. I want the counter to start at 1 because we assume that the first element or the first number is already sorted. So I want my loop to start from the second one, which will be 1, because in computer programming, the counter starts at 0. So this is going to be 0, 1, 2, 3, 4, 5, and so on. So I want my counter to start at 1. So 1 is going to be 5, and I want it goes from 1 down to the last element in the array. I is going to be less than the length of the array. And then I also want to increase the counter. So this loop is going to go through the whole array starting at element 1 and onwards. So inside of my loop, I'm going to declare an integer, and I'm going to call my integer current. The current variable will keep track of the current element in the array. I'm going to assign current to the array. I also want to create another variable called j, and j would also be a counter, and I'm going to initialize j to I minus 1, and j looks at the current element, which will be in the array, and it will look at the current element that goes left of the array. So for example, if I want to make a swap between 6 and 3, j would look at the current element and goes back in order to make the swap. And then I want a condition, so I can say while j is greater than equals to 0, and I also want to check as long as the array j is greater than the current element we're looking at, I want to assign the array, which is going to be j plus 1, and I'm going to have it equals to the array j. That specific lines of code inside of the while loop is going to do the insertion for the array. It's going to shift the array, and then we want to place the number inside of that position that just got shifted. So we want j now to equals to j minus 1, and then we want to place the current element inside of the position that just got shifted. And to do that, we want the array, which is going to be j plus 1, is going to equals to the current position. And that's all you need to write an insertion sort. Now let's print the values inside of main. Let's declare an integer called length, and the length is going to be equals to the array, and we want to call the insertion sort function. Inside of the function parameter, we need the array, and we also need the length of the array to pass through as well. And in the bottom, we're going to print the values. So we also need a loop to print the values. And we're going to use the famous cout statement to print the values of the array. So let us build and run the program. And you can see the array is sorted from smallest to largest.